2 out of 3 ain't bad.
Ready? Hey, it's Alex Williams of the New Stack here at the Cloud Foundry Summit in Philadelphia, here for our first discussion of the day. Our discussion topic for our first interview is about interoperability and how it enables building for the future, a big theme here at the Cloud Foundry Summit in Philadelphia. I have as my guest today Dr. Xiùjiāo, who's a client lead and cloud engineer at Stark & Wayne, Bernd Krannich, technical lead, Cloud Foundry, SAP, and Julian Friedman, Cloud Foundry project lead at IBM. Thank you all for joining us.
Thanks for having us.
Great. So I wanted to set the level set, okay? Because one of the things we're going to be talking about is interoperability, but it encompasses so much. And one of the interesting, developments that I think is apparent inside the Cloud Foundry Foundation and the cloud native ecosystem overall is, the concept of how do you think about container runtimes? And Irene is a new container runtime, and newer, where it's now becoming available more, and I'm curious on how that is a step forward, because there have been other environments similar to Irene up to this point.
So
maybe you could just explain Irene.
So Irene is Cloud Foundry on Kubernetes. So pluggable scheduling for Cloud Foundry. So historically, the only thing that you could use to do container scheduling in Cloud Foundry was Diego, which is the custom-built container scheduler. And the reason for that was we built it before there were any other container schedulers. So we had to build our own, right? If you want to build a CF push experience, you're going to need a container scheduler. One didn't exist, so we built one. There are now commodity, almost, container schedulers, real standard container schedulers. I'm obviously talking about Kubernetes, where you can get that as a service from a whole set of cloud providers. Being able to let people use that means we can deliver them a CF push user experience wherever they want a CF push user experience. And I think that's the big value, is broadening the amount of places you can have a CF push and broadening the ecosystem, because the Kubernetes ecosystem is so strong now. Being able to take advantage of that is a huge thing.
Mm-hmm.
For what it's worth, I'll say as well, my other hat, so I'm currently the project lead for Irene. I'm also the project lead for Garden within Cloud Foundry. So Garden is our container engine.
There's a similarity.
Right. So within Garden over the last few years, we've gone from our own custom implementation, we called it Garden Linux. We then were the first adopter of runc in production outside of Docker with Garden runc. We're now moving over to Containerd. So we've got a lot of experience of, as these things commoditize, we've moved the platform over. And we did that at the container layer. And now we're doing the same things at the scheduler layer. And we had a lot of value from being able to share code in runc and then Containerd. So we think a similar thing happens with Kubernetes.
So when you say commoditization, and Bernd, maybe you could talk to this, and it means basically that it's the accepted practice, it's the accepted way, the accepted approach. And so, Bernd, when you're thinking about all these environments, Gartner, Istio, Cloud Foundry, what are the benefits of that you're seeing for these environments right now, and what makes them different now than maybe a year ago? Because I think we are starting to see more of the standardization, but still some of these projects are pretty young too.
Right, exactly. So I guess Jules and I and others in the community have been talking about that particular topic of Irene for quite some time, or the broader topic even of Cloud Foundry on Kubernetes, and Irene is an important piece of that for quite some time. I guess it took us quite some convincing, and then also I guess market realities kicked in at a certain point in time, where talking about commoditization, Kubernetes is the de facto standard for how you do container management these days. And so it's kind of clear for Cloud Foundry to stay relevant. You need to be able to respond to those market realities and the evolution overall. The other thing is there's even more new technologies that are being pushed in the market, and like maybe Kubernetes is even one of the more mature parts of that technology stack. So talking about Istio, that definitely responds to another need in a distributed system, which is around a big mesh of microservices talking to each other. And then I guess as we all learn in computer science studies, the network not always being reliable, the service you want to talk to not always being available, etc., etc. So Istio is a technology that kind of transparently for the people that are developing those services deals with a couple of aspects, like how to actually kind of retry a call to another service if that service is not available for the first time. How to do that properly. Like, it doesn't really help to flood that service with requests, but you need to kind of time that a little bit, try after a second, try after two, and then maybe wait a little bit longer. So things like that. Then additionally, Istio brings in capabilities around how do you actually secure that communication between services, where traditionally we have asked service developers to deal with things like TLS encryption and all of these technologies themselves. And now we are basically seeing a trend, and Istio is one of the technologies that helps there, which says, no, actually the people writing those services should be freed from the burden of doing that hard stuff, and there should be common underlying technology that would deal with those aspects. Telemetry is another one, like you want to see which traffic is floating between those microservices, how many calls are made, what data volume is transferred, etc., etc. So this is where I see technologies like Istio.
Dr. Gao, so we were talking before, and you've done some comparisons of runtimes, and how are you viewing these runtimes, and how are you comparing them, and how are you then providing them, as context for your customers out there?
Oh yeah. So actually we have a talk on the runtimes this afternoon, 2:15. So from what I know, there's two types of main runtimes: application runtime, which is Cloud Foundry, then container runtime.
Right.
When we talk about it in this community, usually we mean Kubernetes. But there are other container runtimes, but Kubernetes are like more popular. And then there's system built around them, like how you run them, how you deploy them, how they work together. So we try to see like what your team or your company need, then try to see what's the better fit for your requirement. Because I see this community is really rich and diverse. Let's say what Jules mentioned, Irene, basically bring, as he said, bring the CF developer experience to the Kubernetes runtime, and then Gardener is use Kubernetes manage Kubernetes. That may be good for company. Their team are very good at running Kubernetes, right? Then their teams may be very knowledgeable on Bash. All those factors play a role when they adopt a certain runtime. Certainly, what workload you want to run, how far you want to scale, all that. Yeah.
Interesting. So Julian, when you're thinking about these runtimes and the experience, what are you finding in terms of the teams that you're talking to about these issues of interoperability and really the maturity of these platforms?
So I think Chip showed a really interesting slide earlier.
Chip Childers.
Chip Childers, the CTO of the Cloud Foundry Foundation. I can't remember the numbers exactly, but it was around 80% of people are using, are evaluating containers. It was about 60% serverless, around 70% PaaS, and most are evaluating 2 out of 3 or 3 out of 3 of those evaluating or using. The thing that interoperability gives you, I think, is the ability to use multiple high-level abstractions, use the right tool for the job, but have them all interact together. So the analogy I was thinking of the other day is you think about C and Ruby, right? C is a great language if you're writing an operating system, maybe not the best language for a web app. Ruby is a great language for a web app, maybe not a great choice for an operating system, right? Like if you're doing it, I want to hear your story, right? Like I'm interested, but I think there may be a better tool, right? If the only way you could use Ruby was if you ran it on a Mac, right? And it didn't run on anything else, Ruby would be a much harder sell, even though you'd be much faster writing a web app with Ruby than C. And I think that's what we've had with some of these platforms, where in order to use the high-level abstraction, you had to buy into this whole other ecosystem, right?
Yeah.
And by having that interoperability between them, we can have more experimentation. Like, you don't have just one programming language, you have a few. And I think you have that because they all work together. I think that's what interoperability can do.
Dr. Gao, does that align, with what you're seeing with your customers, that breakdown in terms of for example, Cloud Foundry versus cloud native technologies, and how they're evolving as kind of as technologists, and how they're evolving really their own production environments?
I think so.
Yeah. So when Julian's talking here, I mean, and he was citing Chip Childers' data about the knowledge of the people who are actually implementing these technologies. How would you gauge that, and how do you then approach them to make sure that they're that they're actually getting what they what they really need? How do you compare the runtimes to maybe a better way to ask this question is how do you help them understand these different runtimes? How do you help them understand these different abstractions? How do you help them understand these different technologies?
I think I will start from what those runtimes bring to you.
Yeah.
Then ask question, what do you need? Let's say if some companies they run more like cloud native apps, maybe their team don't do containerized apps, then probably I will talk more about Cloud Foundry. But if their team is very heavy on containerized workload, then there's like a Kubernetes, Arena, or Gardener, all those. Probably you will introduce them to those.
Are they wanting to use? Are you seeing more interest in containerized workloads?
Oh, I do. Yeah, I do. Because I mean, the biggest thing I see here is what a developer like about it is you got a consistent way to run your apps. So regardless is your laptop or is your dev environment or product environment, so they can have this consistency. Certainly, there are also other benefits. Yeah.
Okay. Yeah. Thank you. So, Bernd, I mean, what are you seeing, from your user base about their level of experience and how are you helping them reach these, understand these higher levels of abstraction, so they can actually kind of, use them appropriately?
Yeah. So I think it's a similar conversation. So essentially, we in our product offering have started with providing Cloud Foundry. And obviously, as I said, due to market demands and I guess also marketing, there's more and more people saying, give me Kubernetes. And this is where Gardener, as an SAP-initiated open source project, comes in. So Gardener essentially is a Kubernetes as a service offering, but in the form of an open source project. And we use it at SAP to provide Kubernetes technology to our user base. However, I would say we have similar conversations around what do you actually need? Like, do you want to have this, here is my code, run it in the cloud for me, I don't care how experience, where people really can and want to focus on solving a particular business problem, and that comes with kind of certain restrictions on how that business problem can be solved. So microservices, HTTP-based, oftentimes stateless apps, stateful backing services, or is it more a different workload where people say, I already have like a legacy application that I'm not able to rewrite in a short time frame. I want to talk various protocols, non-HTTP protocols, etc., etc. I have particular requirements towards the underlying hardware, and this is where we then usually kind of offer the next lower layer, which is actually Kubernetes directly. But that again comes with additional responsibilities, because quite a few of the properties that Cloud Foundry provides you out of the box, just to name, like automatic security patching of the underlying operating system and libraries, this is then definitely something that these end users will need to take care themselves, and that is usually quite a steep learning curve for those people.
Would you add anything to that, Julian?
I think that makes sense. I think that makes sense. I think you do see a gradation of abstractions, where I think most people should try to use the highest level abstraction they can, but no higher, right? There's always a danger of the leaky abstraction, right? You always want to use the abstraction that does fit your use case and not struggle against it.
Why is it called a leaky abstraction?
I don't know.
But what is your view? What is a leaky abstraction?
So I think a leaky abstraction is to me, it's an abstraction that doesn't fit the problem you're trying to solve. So you end up having to work around the abstraction. So when the abstraction, so if you think about computing in the last few decades, right? You've gone from like DOS to like a man on the moon to driverless cars, right? With the same same chip
cloud
brains,
services
right?
somewhere in between.
Right. All the way to like being able to order an ice cream via an iOS app, right? The pinnacle of technology, right? We have the same brain size throughout that, but we're able to solve bigger and bigger problems. And the main way we've done that is higher and higher level abstractions, right? We don't any longer think in terms of the machine level. We moved up. If you think about what was the original infrastructure as a service cloud, it's data center-less computing, right? Give me a server. I don't care if it's a server in row J4 or K2. Just give me a server and I no longer care about it. And that infrastructure as a service abstraction was extremely powerful because it made me not care about those details. The problem is if I have a use case where I do need to care about those details, then it's no good to me at all, right? If you pick a bad abstraction, then it gets in your way more than it helps. But that doesn't mean that you don't need high-level abstractions. You do. You need the ones that fit you. So I would give the example of serverless. I think for a lot of people, serverless is a great fit for what they're doing. But also for a lot of people, it's a very high-level abstraction that doesn't fit their problems. So I think at the moment, if you just have a world where there's serverless and containers as a service, you're kind of either at a too low abstraction or a too high abstraction. And what I think PaaS can be for a lot of people, that 12-factor app thing, can be the sweet spot between the two, where you have stateless apps, but you don't have to have them all be event-driven functions. You can have stateless 12-factor apps, push code to a platform. It's on the journey towards serverless, but at a lower level of abstractions. That gradation of abstraction as you go up. And coming back to the interoperability theme, if they're all on the same platform, if you have a platform that gives you functions and apps and containers, and they all interoperate seamlessly, then you can choose the right abstraction.
So Dr. Gao, so when you're looking at different runtimes, how do you compare the abstractions of those different runtimes? How do you, are there, when you're doing your research, right, what are you looking at in these abstractions?
Good question. Actually, I don't know.
Yeah.
I don't know.
When your own research then, tell me more about the research you've done on these runtimes and how, so what are some of the inherent differences you're seeing in them, for example, comparing, Xiùjiāo to Gardner to other runtimes, and how are you helping them, how are you seeing the differences in the abstractions in comparison?
So I don't know how to answer this question.
Okay. So maybe I'll try it again. So when we're talking about these abstractions, right, and we're talking about and how the abstractions have become more familiar, right? How do you view those abstractions? How do you look at those abstractions for your own customers and help them understand how to use these services and these technologies?
I do see that abstraction make life better. If I talk about old times, if you want to deploy a software let's say you even don't have the hardware, you may have to request, okay, get a computer, then install operating system, then configure, then you may install your software, right? Nowadays, you don't have to do that because the first layer of abstraction, like the VMs, you don't have to deal with the hardware, you can do VMs, that's virtual machine level. The next level, okay, VMs, but if you run your thing, you have to have the libraries, packages supported, right? Then comes the platform as a service. So you don't have to worry about those. You just worry about your apps. Then another layer goes up is, okay, if you have your thing in the container, you ship it can run everywhere, right? Like consistently. So does that answer your question?
Yeah, I think so. And I'm sorry if I wasn't clear enough. I think I think what we're finding is that there's just kind of this new way of building applications, and it's through components, and through those microservices, for example.
Yeah.
And those microservice architectures then have to be usable, so you have to be able to understand how to use them.
Yes.
And that gets into then I think the discussions about, does the abstraction make sense? Is there an abstraction really? What is the value and the need for those abstractions? I'm looking for the patterns in that. What are those different patterns you're starting to see with customers and their adoption of these different abstractions?
Yeah. To me, it's more like with that abstraction, there are things you were worrying about. With that, you don't have to worry about it. That's the big thing I see from it.
Right.
Yeah.
So how do you see the evolution of those abstractions, Julian?
So I think we've definitely. So one thing I think is interesting is in technology, you always see good ideas come back around and around and around. And it's very rarely just a straight line from good idea to success of idea. Right? Very often, good ideas actually fail and then come back and fail and then come back and fail. I always think of the iPhone, right? Like if you looked at all the previous touchscreen phones without a keyboard, what you could take from the data was no one wants a touchscreen phone without a keyboard, right? And then Steve Jobs gets on the stage and shows you this touchscreen phone with a keyboard, and it's clear that that was the next big thing. So I think we've got a set of technologies at the moment that have elements of where we might be going. Some of them will succeed now. Some of them will come back in a new iteration before they succeed.
So, Bernd, what's coming back?
So what's coming back? I think like one discussion that's definitely coming back is for certain problems, those distributed architectures are actually oversized. Like you don't need to build a distributed architecture if all you have is just an idling website that is serving a couple of requests, and like you have a database attached to that. Like no need to cut that into 5 microservices that call each other in complicated patterns and maybe create more issues than they solve. So that is definitely something that's coming back, but I like similar to that spiral of technologies like showing up and going down, I see like a pendulum pattern actually evolving. So like initially all people did those monolithic applications and they kind of found out about all the bad properties that those had. So like the pendulum swung in the direction of microservices because that was supposed to solve all those problems that people were seeing, quote unquote, in the old world. Now all people are doing microservices and they see the issues with those. So the pendulum is kind of moving again in the other direction. And that is, I think, also a constant pattern that at least I'm observing in technology.
Does that make sense to you? Do you see that?
Yeah. I do see that. On top of that, to me, I think it's also more the diverse. Like, let's say, this trend may come back now, but what I see is in the same community, you have so much different effort from different angle to satisfy different needs and requirements, because there are always different user case, different needs, right? Mm-hmm. So yeah, I also do see that. Yeah.
Any last talk, Julian, about about where where you see things now in terms of that this adaptation that we're starting to see with developers and really the organizations that are trying to adopt this change?
Yeah, I think the exciting thing to me is now that we've got that that almost dial tone in Kubernetes, that base layer.
Yeah.
We can start to have conversations about what the high-level abstractions are on top of that, while still letting everything we do work together. I think that's really exciting. That's how you deal with this problem of how do I pick the highest level abstraction? Because you let people have an escape hatch, right? So pick the highest level abstraction, but give you a way to drop down when necessary, come up when necessary, right? So you can iterate towards the right level of complexity, the right abstractions for what you're doing, right? If you have a platform that has functions and apps and containers, then you can choose the right thing for each bit of your architecture and have it all work together.
Well, thank you so much for all of you for taking the time to talk with us and discussing how these different, how interoperability really is changing and the comparisons of these different runtimes. So thank you, Dr. Gao, and
yes, thank you.
Yes, and Julian and Bernd Krannich, thank you very much for your time.
You're welcome.